Have you ever wondered how the same computer you use to send an email can also be used to design a skyscraper, pilot a drone, or even simulate the human brain? The secret lies in the applications it runs, and today, we're delving deep into this fascinating subject. To begin with, we need to understand that every computer, regardless of its size or purpose, operates on a binary system. It's a world of ones and zeros, where every piece of information is broken down into binary code. This code is then processed by the computer's central processing unit, or CPU, the brain of the computer. Consider the example of typing a letter in a word processing application. When you press a key, the keyboard sends a binary code to the CPU. The CPU, in turn, interprets this code and sends instructions to display the corresponding character on the screen. It's a simple process, but it happens so fast that it seems instantaneous to us. Output. Now let's shift gears and think about a graphic design application. Here, the CPU has to handle much more complex tasks. It needs to process the shapes, colors, and textures you're working with, and then render them on the screen. To do this, it often works in tandem with a dedicated graphics processing unit, or GPU. The GPU takes on the heavy lifting of rendering graphics, freeing up the CPU to handle other tasks. But what about applications that require real-time interaction, like video games or simulations? These applications not only need to process complex graphics, but they also need to respond to user input in real time. This is where the computer's memory and storage come into play. The CPU constantly reads from and writes to the computer's memory, allowing it to keep track of the game state and react to player actions. Finally, we have applications that require vast amounts of processing power, like scientific simulations or artificial intelligence research. These applications often run on supercomputers, which are essentially networks of thousands of CPUs and GPUs working together. By dividing the workload among all these processors, supercomputers can perform trillions of calculations per second. So, to summarize, at its core, every computer operates on a binary system, processing ones and zeros. Depending on the application, different parts of the computer are utilized to perform the necessary tasks. For word processing, it's mainly the CPU and the display. For graphic design, the CPU works with the GPU. For real-time applications, the computer's memory and storage are crucial. And for high-performance applications, networks of CPUs and GPUs are used to achieve the necessary processing power. In essence, a computer is a versatile tool, capable of performing a wide range of tasks. But it's the applications that unlock this versatility, transforming a machine of ones and zeros into a word processor, a design studio, a gaming console, or a research lab. It's truly a marvel of modern technology.